Greetings, medics. Welcome to some worked examples for the quantitative reasoning section of the UCAT exam, and we're going to be looking at forming equations from words. Let's go. So we've got a medical shipment that contains two cases, and what's happening is 4 defective items per case are being removed and 5 are being added, and there are 22 items in total for the two cases. So how many items were in each case originally? Okay, so X represents the case and 4 defective items were removed and 5 were added. This is for one case. So we can then say that for one case, if we just neaten this up, we can say that one case can be represented as x plus 1. So minus 4 plus 5 is plus 1. Now, we have two cases. So if we have two cases, one case can be represented as x plus 1. So if we've got two of them, we're just going to multiply it by 2, right? And we are told that there are 22 items in total. So all of that is equal to 22. Okay, so we are going to solve for x, which is the number of original items per case. So that's going to be 2x plus 2 is equal to 22. So we're going to take 2 away from both sides. So this becomes 2x is equal to 22. Take away 2, so it's equal to 20. So x is equal to 20 over 2, so x equals 10. Nice. Okay, simple as that one. Okay, question number 2. A hospital's rectangular triage area has a perimeter A. Okay, so there's a sketch. Write a formula to find the length if you know the width and the perimeter. So let's call that L, let's call that L, that's W, and that's W. Okay, so we can say that the perimeter is that length plus that width plus that length plus that width. So we can say that the perimeter, which is A, is equal to L plus W plus W. So A is equal to 2L plus 2W. So we need to write a formula to find the length, i.e. L, if we know the width and the perimeter. So the width is given by W and the perimeter is given by A. So if we subtract 2W from both sides, we will be left with A minus 2W is equal to 2L. So just add that in there, and that cancels the 2W out. So then, to get L on its own, we're going to divide both sides by 2 to free up that L, and then A minus 2W all over 2. And done. That's it. Okay, next question. Okay, question 3. Looks a little bit more heavy, a bit more involved. You've got an ambulance which is transporting a critical patient 180 miles, ouch, to a specialized hospital. So for the first 2 hours, it maintains a speed of 70 miles per hour. Okay, so it's a speed, distance, time calculation. So we've got the time, and we've got the speed, so we don't know the distance covered. So step 1, I would say distance covered at 70 miles per hour. So speed is equal to distance over time. So to work out distance, distance is going to be equal to speed times time. So distance is going to be equal to the speed, which is 70 miles every hour, multiplied by the time taken, which was 2 hours. So my distance covered was 140 miles. Okay, so then let's have a look at the next step. Where do we go next? So we're covering a total distance of 180 miles, but we've covered 140 miles at 70 miles per hour. So remaining is 180, take away 140. So I've got 40 miles left. Okay, so if I've got 40 miles left, that is clearly a distance. And if I keep on reading, it tells me the average speed drops to 50 miles per hour. So I've got a distance and I've got a speed, right? So what variable am I determining? I'm looking at the time taken. So time taken at 50 miles per hour for 40 miles. And you can kind of see where this is going. So my time is going to be equal to the distance divided by the speed. So the distance is 40 miles and the speed is 50 miles per hour. They cancel out. So I can simplify this to 4/5 of an hour, which is equal to 0.8 hours for that 40-mile distance at a speed of 50 miles per hour. Okay, so where do we go next? Now I'm thinking, let's actually answer the question. So to answer this question, write an equation to represent the total trip time. So the total trip time is T star star is equal to my 2 hours plus the time spent traveling at 50 miles per hour plus X star star. Cool. So then number 4, how many hours the ambulance traveled at the reduced speed? So we already answered this, so this is 0.8 hours. So then 5, total time. Well, I can use my equation now, is 2 plus x, and x in this case is 0.8, so 0.8, so therefore 2.8 hours. Okay, thanks for watching, see you next time.